All right, good evening, guys. So welcome back once again to another series. So in the previous series or episode, we look at the ERC-721 token standard. That is the fungible token standard. Yeah. So in this episode, we'll be going through the ERC-721, that is the non-fungible token standard, or what most of us know as NFT. So we are going to first of all start through going through the abstract and the method specifying in the EIP 721. So from there, we now scale down to look at the interfaces, the standards implement. Then we now go in depth to understand things that you need to implement in this interface as a developer. Then after going through the interface, the next thing is to go through how we now build up the code. So build up the code, I'll walk you through step by step to tell you everything that happened in each line of the smart contract or in each line of the code for an ERC-721 contract. So stay with me, it's going to be an awesome ride. Let's get started. So first of all, the EIP, that is a self improvement proposal. So this, the 721, now is now an ERC because it has been implemented. So in simple summary, so it's a standard interface for non-fungible token and also known as DEED. So there's what we call tokenization. So tokenization is the conversion of physical assets into digital assets, right? So NFTs, they are more of tokenized assets, but there is one unique thing about them is that they are not divisible. So that means no two NFT can be the same. What do I mean? Let's bring it down to what you can relate easily. Now, looking at yourself, you are an NFT because there can be two persons that has the same traits, the same character, the same everything, the same facial appearance and everything like you. So you're already an NFT. Yes, so boy, in the crypto space or in the crypto economy, we look at NFT, we see NFT as the non-fungible tokens or what we know as deeds. And deeds, they are somehow contracts. But these contracts, they have value, they have monetary value, and they represent a stake in a physical asset. So that is just a quick intro about NFT. So there are so many more to NFT. Then as we walk through this video, I'll be going in depth to still tell us some things about NFT as we but now let's look at what these standards are. So like I told, the NFT, they could represent physical property, maybe your houses, your artwork or whatever. They could represent virtual collection, unique pictures, or whatever. They could also represent loans, burdens, whatever you can think of. Anything, any digital assets you feel like can be tokenized, that is, can be converted to digital assets, you can actually represent this guy as NFT. And the most important thing is that you want this asset to be unique. Unlike what we saw when we are looking at ERC-20, so these guys that are not unique, but NFTs are unique. So if you want everything to be unique, that means you want to treat it as an NFT. So these are the interface that every NFT contract must comply to. So when we say that it must comply to this, that means if I have an NFT and you have an NFT, so if we are using the same standard, it's easier for my NFT to interact with your NFT, or if you have an application that wants to interact with my NFT, that means since it's implementing this standard, the interaction will be there. It's easier for that your contract or your application or whatever to use the function prototype and interact with my NFT or whichever way. So that is why it's a standard. So being a standard means that every NFT smart contract must implement it. It's a must. is a must. That's why it's a standard. So you need to follow the standard while building it. So let's now go through the interface and understand what this interface are saying. Then from there, we enter the main contract proper. So this is just the whole interface. Maybe in your free time, just take your time and go through it. You get. So, but what I want to do now is I'm going to copy this interface to VS Code, then explain it line by line, because I don't want to start explaining it here. It might not be clear, but these are just what the whole interface. So let's go to VS Code, see the method that this interface implements and understand it proper. Now, the first question you should ask yourself, or probably you might be asking yourself right now, is what are these interface you get? So interface, they gives you access to the function prototype, so which help you to easily interact with any smart contract that implement that interface. So when we talk about function prototype, is a combination of the function name and function parameters. I know it might not be clear at this point, but stay with me. As we walk through this interface, I'm still going to explain it more when we enter the function selector side. Now, so the interface specify the function name, types of parameter, and the whole of that. Then for you to actually interact with any smart contracts on chain or off chain, you need two things. You need the ABI and the contract address. So the interface is somehow similar to the ABI, that is the application binary interface. So now this is interface for ERC-721. So the first thing you see is the events. Now, if you recall on the previous on ERC-20, we have 2 events, but on ERC-721, we have 3 events. So the 3 events are transfer, approval, and approve for all. So the transfer event, so it emits when the ownership of an NFT changes by any mechanism, maybe either via transfer or via approval. So it emits this event. Now, the approval event, this is emitted when the address approved for an NFT is changed or reaffirmed. Okay, if I approve you to be an operator on my NFT, so anytime I give approval, this event will be emitted, and anytime the approval changes, this event will also be emitted. Now, when you query, when you have 0 address, indicate that there is no approval. So we are going to see this more when we look at the function on which this approval triggers. Then we have the approve for all. Yes, so this emits when an operator is enabled or disabled for an owner. So the owner can change all NFT of the operator can manage all NFT of the owner. So these are just the main 3 events that this standard implements. So these are the main events that this standard implements. So that means that you now, in building your own smart contracts, maybe if you have maybe mint or bond function, you now need to create your own events. So that means these guys are not part of the standard. Just like as we saw in ERC-20, the mint and bond are not part of the core standard. So the same thing is happening here in 721. So as you go down, you are going to discover that the mint and bond are not part of the core standard, but you as a developer, is you now that is not going to bring in more functionality that you need. But first of all, you need to implement the standard first. So the first thing, the first function or the first prototype is the balance. This is quite similar to what we have in ERC-20 tokens. Okay, so the balance, it returns the count of all NFT. Now, remember the NFTs, like when we are looking at ERC-20 token, we are looking at, okay, how much money you have in your balance. But here now is an NFT, so we are looking at the count. So what the balance of does is that once it queries an address, so once you pass in an address to it, it's going to query the address, then return the total number of NFT owned by that particular address. Yes, so the NFT owned by that particular address is what is going to return. So the NFT assigned to the zero address are considered invalid. So if you assign an NFT to zero address, so it's invalid. So and this function throws for queries about the zero address. So if you query for zero address, definitely it's going to return zero for you. So the owner is an address for whom to query the balance, you get. So the return type for this guy is UN256. That's which is going to definitely is going to be a number. Now, since this is a balance and it's taking in an address, now as a developer now, in your mind, you should be thinking of, okay, what type of data structure do I actually need to be able to achieve this? So that means in your contract, you are going to have a mapping that is going to map to the address. So taking the address as the key, because this function is accepting an address. So definitely you are going to take in address as the key, then you are going to return the balance or the count, the number of NFT owned by that address. So definitely in your smart contract, you are going to have a mapping that is called balance. So we soon see this guy when we enter the smart contract. Now, another function prototype we are going to look at is the owner of. So the owner of, it finds the owner of an NFT. So what this guy does, that remember NFT, they are unique. The IDs are unique. So once you pass an ID to this function, so it queries to know the owner. So how do you know the owner? Once you pass an ID, it queries and it's going to return an address. I know that in EVM and Ethereum, in EVM and blockchain generally, address are unique. So no two address can be the same. So once you pass this guy, it's going to return an address for you. It's going to return an address for you. What to that? All right, so I think I'm on pause mode. So once you pass the token ID on this function, it's going to return the address that owns that particular NFT. So now it queries the NFT assigned to zero address are considered invalid. They are the same thing we have. So the parameters, we have the token ID, which is the identifier for an NFT. So this guy is going to return an address. So once it does the query, it's going to return an address for you. Tells you, okay, for this ID you pass, this is the owner of the NFT. So now, just like as we saw in balance swap, so definitely we are going to have the mapping that is in our smart contract now, in our ERC-721. So we are going to have a mapping that is going to take the token ID as a key to return the address as a value. So that is mapping. There are another function that the interface implements is the safe transfer form. Now, the safe transfer form, so you transfer the ownership of an NFT from one address to another. Now, it throws that is, before it does the transfer, it has to carry out some security check using your required statement. So that means in writing the smart contract for this guy, you are going to have a required statement that is going to first of all check that the message the sender is the current owner. So if the message or sender is not the current owner, it's going to throw that is going to revert. Then it will also check that an authorized operator or the approval address for this NFT. So it's also going to check, okay, is either if the message or sender is owner or the operator, whoever that is calling that function is an authorized or approved operator. So it also throws if from is not the current owner. So if the message or sender or the former address is not the current owner, so it's true. So this true, whenever you are going through the next Netscape doc and you are seeing through, is actually trying to tell you, okay, these are some of the security features you need to implement in smart contract. Okay, if this doesn't happen, if this doesn't work, so you need to try an error. So these are just what this guy is. So, and also the name of this function is safe transfer form. So that's why it's called safe transfer form. Now, before this function be successful, it has to do another thing. It has to check. It has to call the ERC-721 received. Now, this function, this particular method makes sure that the NFT or the DOA or the smart contract can receive an NFT. So this particular checks to make sure that, okay, the recipient, the address to, if it's an NFT contract, it will check if it implements this particular interface. And this interface that allows any NFT contract to receive NFT. Now, but if it is an EOA, it might not actually do the check because by default, an EOA can receive NFT. So that is why this guy is called safe transfer form. So we still have transfer form and transfer. So another check that it does is it makes sure that the token ID is valid for the NFT. So these are just some of the things this guy does. So it checks the from address, the to address, the token ID. Also, it also has the buy data. Now, we also have another function. Now, there's what we call function overloading in smart contract. In function overloading, you are going to have two functions. Like if you check, we have safe transfer from here. We also have safe transfer from here. But if you look at a parameter, you see that this guy has 4 parameters. Why this guy has 3 parameters? So we have function overloading. So when two functions, they have the same name, but different number of parameters. So they are valid in Solidity. Okay, so that is what we call function overloading. So exactly, that is what is happening here in this particular prototype. Then the transfer form. So you transfer the ownership of an NFT. So the caller is responsible to confirm that the Tor address is capable of receiving NFT, or else they may be permanently lost. So that means before you can actually call this function successful, you need to carry out some security check to make sure that the recipient, that is the address to, implement the ERC-721 receive interface, this ERC-721 receive interface. So you have to check and make sure that it implements it. So if it implements it, that is the only way that NFT contract can receive NFT. So if an NFT smart contract does not implement this, you can't transfer an NFT to it. So if you transfer an NFT to it, it will be permanently lost. So that is for smart contract, but for EOA by default can receive NFT. So it also checks that the message or sender is the current owner or an authorized operator or the approval address for this NFT. So also it throws if form is not the current owner. So these are just some security check that this function has to undergo before it's actually becomes successful. So we have the approved interface or the prototype. So it changes or reaffirms the approval address for an NFT. So 0 address indicates that there is no approval. So when you query with when you pass in the address and the token ID for a query, if it returns 0 or if you have a 0 address, definitely it indicates that there is no approval. So this guy also checked that the message or sender is the current owner of the NFT or an authorized operator of the current owner. So these are just some security check you have to do in your smart contract. Okay, require that message or sender is equals to owner, or that the approval address is in the approved mapping. Then to also check the token ID and to make sure that the token ID has already existed. So that means the token ID you want to approve has been minted, because you can't approve an NFT that is not in existence. So also carry out that check. So we are going to see this check more when we enter the smart contracts. Now we have the set approval for all. Now, so it enables or disables approval for a third party to manage all of the now this guy is a very dangerous function. So you should mind how you use this particular function, set approval for. This function is a very dangerous function. So you should mind how you use it. Why? Because this guy is setting approval for all of your assets. He's setting approval for all of your assets. So this guy is this particular function, hackers are taking advantage of it. Because if by phishing attack and the whole or front running, I was able to give you approval. So that means if I give you approval using the set approval for all, that means all my NFT, you have access to it. So this is a very dangerous function. You should mind how you use this guy. So it's a meet and approval event, and the contract must allow multiple operators per owner. So that is what set approval for all. So you can use it to set different addresses that is, you have multiple operators you can allow to manage your assets. So that is set approval for all. Then we have the get approved. So it gets the approval address for a single NFT. So it throws if the token ID is not a valid, it's not a valid NFT. So it's once you call this function, it's going to take in the token ID as a parameter, and it's going to return address. It's going to return address. So once you query the token ID, if the token ID, once you query the token ID, it's going to return the approved address. So we have the is approved for all. So the same thing. So it queries an address and it queries an authorized operator for another address. So the owner, the address that owns the NFT, the operator, the address that acts on behalf of the owner. So just like what we have in ERC-20, where we have the allowance and the rest. So once you query the allowance and passing the address of the owner and the address of the spender, can actually tell you, okay, this is how much allowance this guy has or whatever. So that is something we're having here. So once you pass the address of the owner and the address of the operator, that is a third party that the owner has approved to manage or trade his or her NFT for her. Maybe the marketplace you have approved to trade or manage your NFT for you. So once you do that, now this guy returns a Boolean. So that means it's either true or false. So by default, it's false. So once you query this guy, it's going to return true if the operator is approved, and also if the owner is the owner of the NFT. Now, on your contract, so that means you are going to have a mapping that is going to map address. So that is address of the owner to the address of the operator, and it's going to return a Boolean that is either true or false. And you know that Boolean by default they are false. So that is, these guys are the main ERC-721 token standard. But we still have some more. Now we have ERC-165. So ERC-721, if you look up, you see that ERC-721 actually inherits from ERC-165 for a reason. So I will still explain that. So what this ERC-165 does is that it provides a function signature called support interface. So, and this guy, it take a byte for that is the interface ID, and it's going to return a Boolean. So it queries if a contract implement this interface. Okay. Now, if in the interface ID, so this guy specify, okay, we should go to ERC-165. So this guy returns true if a contract implement this interface. So we are going to see more of this guy when you be looking at marketplace and the rest. Now, this is another very important function or interface that is on ERC-721 receive. Now, this particular interface is what is called whenever you are transferring an NFT using safe transfer. So you have to first of all call this interface. So what this interface is going to do is going to check and make sure that if it's an NFT contract, it will check, can this NFT contract receive NFT? So it can only be able to receive NFT if it implements this interface. If an NFT contract did not implement this interface, you can't send any. If you send NFT to it, that contract can't receive it. So it's a must. So all NFT contract must implement this to be able to receive NFT. So if you want to receive NFT, you must implement this. But for EOA, you don't actually need it because by default, they can receive NFTs. So that is what this interface does. So I just drop a hint here. I say that a wallet or broker option must implement the wallet interface if it receives safe transfer. So whenever you call the safe transfer form, it carries out a check on DOA or smart contracts and make sure that this guy can actually receive NFT. So by default, all EOA can receive NFT. Thus, you need to implement this in your contract if you want your contract to receive NFT. So you need to implement this interface. So when we go to the contract, we see how this interface is implemented. So in the implementation of this interface, it takes the function prototype. So this is the function prototype. Okay, so function prototype is a combination of the function name and the type of parameter it accepts. So that is what we call function prototype. So okay, I think I have some little notes here. So function prototype is, this is the function name, this is the parameter that the function takes. So these are what we know as the function prototype. Now the function signature is the hashing of the function prototype. So that is the KECAC 256 of the function prototype. So that is when you have a function prototype and hash it, you get the function signature. Now we now have the function selector. Now after hashing the function prototype, that is, you are now getting function signature, which is of bytes 32. Now the first 4 bytes of this function signature are what we call the function selector. So the first 4 bytes of the function signature are what we call the function selector. So basically, in implementing this on ERC-721 receive, you are going to hash the function signature and get the function selector. So that is what this guy is going to return. It returns byte 4. So it returns the function selector. So whenever this function is called, it returns the function selector to actually know, okay, this guy can receive NFT or not. So in implementation in your contract, you are going to carry out this as one of the requirements. So we are going to see how it's done. So let's look at the ERC, the interface for the metadata. So metadata just gives you more details about the NFT. So in the metadata, you'll now be able to see the NFT name, the NFT symbol, and the token URI. So token URI contains more info. So the URI is a resource identifier for every given NFT. So through the URI, you can actually get more info. Then the metadata is like a JSON file. So it's like a JSON file that contains more information about the NFT. So let me quickly open my tab and show you a metadata and what these guys looks like. So this is just how a metadata looks like. So it's going to give you the name of the NFT, the description about the NFT, maybe any external link. This might be external link to your marketplace, your website, or whatever. Then the image. So this is going to be the image URL. So once you click on this image, it's going to take you to where that particular image is hosted, maybe either in your Pinata or IPFS. So when you upload we still come here to understand how we upload the image to IPFS or Pinata and get our CID. Then you have the attributes, the thread type, the value, and the whole of them. So these guys are what we call the metadata. So that is what the metadata interface is trying to explain to us. So there you have the name, the symbol, and the token URI. So the URI, it points to a JSON file that conforms to the ERC-721 metadata JSON schema, just like what I showed you. So this is the metadata JSON schema for ERC-721. Now we have the enumerable interface. So what the enumerable interface does is that it lists all features of the NFT. You know, the word enumerable is an English word just to mean to list details. So by the name of the interface already, you should already have an idea of what interface is all about. So the total supply will return the total supply of the particular NFT, the token by index. So it queries an index and returns the number that is in 256. So you get the token using the index. Now, for this guy to be valid, you have to carry out some security check on your contract. Maybe using the required statement. You have to make sure that the index, that the input index is not that the input the index is not more than the total supply. So these are some of the things you need to implement. So security check you need to implement. All right, you also need to so this is basically what you implement on this guy, because you are taking in the index. So you want to make sure that okay, this index I'm taking is not more than the total supply. Now we have token of owner by index. So this particular function prototype or method or interface, whatever, accept the address which is an owner and an index. So it's going to return, So it's going to return a UNT256 that is a number. So enumerate NFT assigned to an owner. So once you pass in an address and an index, so it's going to list all the NFT owned by that particular address. List all the NFT owned by that particular address. So it also has to carry out a check to make sure that the index is no more than the balance. So you don't want to, this just to make sure that you don't waste gas making unnecessary queries. So you have to make sure that okay, you are not requesting for more than you have, and the whole of that. So these are just the interface. So I believe you get a quick glimpse of the interface. So next, we are going to now go to the contract and see how we implemented this interface. Now, so if you still have question or what you don't understand on the interface, you can always drop in the comment section. I will give you answer, or also do more video to explain the interface more if it's not clear. Because as a smart contract developer, I think the first thing you need to do is, before working with any contract, you need to go through the interface, understand the function prototype, understand what the function prototype is telling you to do, understand what you need to implement. So that is the first thing first. If you can understand the interface, implementation becomes a whole lot easier. So the interface is always the first thing you need to do. Try to understand the interface first. If you understand the interface, then you can now narrow down to, okay, these are how I implement this function. Okay, these are some security check I need to carry out. These are some things that need to be true for these guys to work perfectly. So that is that on ERC-721 interface. Up next is we are going to the ERC-721 contract. Stay with me, guys.